this nice little summary here, and I'm going to go through everything that you should be focusing on. Now again, there may be some other things from the beginning that you should be aware of, but again, this is a nice little compact summary that you can use to study. So for the first one, it's asking us to identify a central angle. Now this was from the beginning of the chapter, but you still need to know what a central angle is. And a central angle is an angle whose vertex is at the center. So if I call this angle ABC, remember the angle measure when it's a central angle is also going to equal the measure of the arc. So if I told you that this angle was 30 degrees, then its intercepted arc would also be 30 degrees. So when it's a central angle, the arc measure is the same as the central angle. When it's an inscribed angle, this is an angle, the central angle is formed by two radii. An inscribed angle is formed by two chords. So again, same angle ABC, but this time remember the inscribed angle measure is half of its arc measure. So if this arc AC was 60, then its inscribed angle is half of that, and it would be 30. So here when it's inscribed, it's going to be half of its arc measure. So the arc measure here, AC, is 60, but the angle that forms that arc is half of that. Then when we have an angle that's formed from two chords, this was my floating angle theorem. So for example, if I draw in two chords here, and if I wanted to find, say, the value of x here, I would take angle X's intercepted arc, and let's say I tell you it's 30, and then its vertical intercepted arc, which would be 50, then I would just take the two angles, add them, multiply by a half, or divide by 2. So X would equal 80 divided by 2, or 40 degrees. When I taught this, this was called what I named the floating angles. So you take the two intercepted arc, the intercepted arc of the angle, and the intercepted arc of its vertical angle, add them and divide by 2, or multiply by a half. So when we have an angle that's formed by a chord, so I could draw a chord and a tangent, we know that this angle that's being formed is going to be half of its intercepted arc. So its intercepted arc could be right here, and let's say it's 100, then I know X is going to be half of that, and X will be 50. So when you have an angle formed with a tangent and a chord, it's always half of its intercepted arc. Then we have the external angles. In the purple section here, all three have the same formula. It was the big arc minus little arc, and either times by a half or divide by 2. And again, I like divide by 2. And then remember, this equals the outside angle, or the external angle. So let me draw the three scenarios. So when you have two tangents that are drawn, it looks like the snow cone or the ice cream cone. So here what we would do is big arc is in red, little arc will be in blue, and then the angle, the outside angle we're looking for is going to be this angle right here. So X would be the outside angle. So red is big arc, and blue is going to be little arc. It's the arc that's closest to that outside angle. Then when I have two, I change the color here? Okay. So when I have 2 secants, what I'm going to do here, still the same thing. Big arc minus little arc is going to equal this outside angle. So red is big, blue is little. Same thing when it's a tangent and a secant. We're still doing big arc minus little arc will give me this outside angle of x. So red is big, blue is little. So subtract, divide by 2, or subtract and multiply by 1/2. Then when we're looking for the lengths of the segments, so for example, if I have 2 chords here, and let's say I label these with letters A, B, C, D, and E, remember that when 2 chords intersect, it forms 2 little segments. So I have that little piece here of AE, and then when I multiply it with its other segment, EC, it's going to equal the other chords products. So DE times EB. These products of the segments are what's congruent. The chords are not congruent. So that's 2 chords. When you have 2 secants, so let's say I have 2 secants here. Remember this one, this formula is whole times external equals whole times external. So my whole on that one could be this. The external piece is this piece. And then on the other one, this could be my whole secant. And then its external piece is that little piece outside. And then the last one is a tangent and a secant. So here's my secant. There's my tangent. So this one is going to be tangent squared is equal to whole times external. Now, one other angle that's not mentioned here is the circumscribed angle. So let me go ahead and just add that one in here before I do 10/7. This bottom part is the standard equation of the circle. I'm going to add that. It cut off on mine. So if you have a circle, and let's say we have a circumscribed angle, remember its measure, if I put an X here, is just going to be 180 minus the central angle that has the same intercepted arc. So here you would just do 180 minus 135, and that would give you X. And this was for the circumscribed angle. Sorry, that's 45. Would equal X. Now we're going to do the standard form of the equation for the circle. So when we have a circle and when its center is at the origin, meaning 0, 0, the standard form of the equation, this is 10/7, is x squared plus y squared equals radius squared. When we have a circle, when the center is not at the origin, it's at the order pair HK, then we have the longer formula, and it's x minus h squared plus y minus k squared equals the radius squared. So what you would be filling in is your h value, your K value, and then you'd also fill in the radius and square it. Now the other formula, when you're given a point on the circle and the center, you need the formula to calculate the radius. And that's the same formula for the circle, what I just wrote up above with the HK. The only difference is the equation is under a radical. So it's exactly the same formula as this, but because you're solving for an r squared, you put it under a square root. So that's a nice little summary of the last 3 lessons of the chapter, which is what your test is on. Tomorrow you have a test. It's on 10.5 to 10.7. There are 16 questions on the test. Now, I know at the beginning of the chapter, I had said that you will probably have a proof. There is no proof on the test tomorrow. So 16 questions. The majority of them are all just calculations. You will have a real-world application problem, just like in the review that was posted. It's the review that's titled Extra Review. So if you are limited on time and you don't have enough time to do both reviews that I posted, I would do the review that is titled Extra Review first. And then if you do have time, go back and also look at the Practice B reviews that I posted. Now, another good thing to always review are your warm-ups. And this is why I want to also quickly go through the 10-7 warm-up. Because since there's only 3 sections on the test, pretty much these 16 questions are equally spaced out. They're, expect to get a minimum of 5 questions per lesson. So just make sure you understand all the formulas that are associated with each one of the lessons. So this is why I added, so here it just wants me to write a standard equation of a circle when the center is at the origin with a radius of 2.5. All you have to do is use this formula, and all I'm going to do is replace my radius with 2.5 and square it. And you can use your calculator. So x squared plus y squared equals 2.5 squared. Once I square that, I get 6.25. So do not leave it as 2.5 squared. Actually do the math. That easy. So if you know the formula, when the center is at the origin, all you're doing really is squaring the radius. You'll also get a question where the center is not at the origin. So this is going to be my H, this is my K, and then this is my R. So I'm going to plug it into the formula, x minus h squared plus y minus k squared equals the radius squared. So I'm going to fill in. My h is a -3. So what I want to see you do is when the order pair, one of the numbers is negative, simplify this to a plus sign, the negative. Then here, y minus k, 5 is positive, and then I'm going to put my radius here. And then now I'll go ahead and just rewrite this part, but then I got to square the radius. And that would be your standard form. So it's just a matter of plugging in 3 numbers. Also be able to find the center point and the radius given an equation. So remember, my h value is here, my k is here, and this 9 is actually the radius squared. Now, for the h and the k, it's backwards of what it looks like. So this looks like what went in here was a positive 1, but remember what went in here was x minus -1. So my h value is -1. My k value is +3. And then my r, I have to square root the 9, and my r value is 3. Now to graph it, you would graph the center point, so -1, +3. And then from that center point, I'm going to move 3 spaces to the left to the right, and up above and below. So 3 down, 3 up, 3 to the left, all from the center point. And then now connect the purple dots. And that forms your circle. And then the last one, I'm going to give you a point on the circle and the center. You need to first calculate the radius, and then you're going to plug everything back in. So for the last one in the warm-up, we're going to first find the radius. We're using this ordered pair. This is going to be, this is my H and my K over here. But then I also have my X and my Y. So I'm going to be plugging it in. So I'm going to plug in X minus H squared plus Y minus K squared, and it's all under the radical. This is the formula to find the radius. So let's plug in the numbers. So my X is 3, my H was 0, my Y is 0, my K is 2. I'm going to go ahead and subtract. I get 3 squared, negative 2 squared, and then I have to square them, add them, and square root. So my R is equal to 9 plus 4, and 9 plus 4 is 13. So my radius is the square root of 13. So now I'm going to take my center and my radius and plug it in to X minus H squared plus Y minus K squared equals the radius squared. So X minus, and again, my H was 0, plus Y minus 2 squared equals the square root of 13 squared. So what I'm going to simplify here is the X minus 0, just make it X squared. Then the Y minus 2 comes down. And then when I square the square root of 13, it just becomes a 13. So be able to do this as well. So this was the 10-7 warm-up. Again, review your warm-ups. They're always very beneficial. So this is a review that I posted this morning. There is a separate file that has the answers. So there is a separate page for each one of the lessons. You will not have a complicated picture like this where you have to find multiple things. A lot of the figures are pretty simple when I'm asking you to find the different angle measures. Now, here is the page from 10.6 and then a page from 10.7. Now, if you are short on time, then what you should do is this one first. This one is titled Extra Test Review. This is the one that I had posted the other day. I had posted this one first. So again, be able to go through these, do all of these examples, be able to do that word problem down there at the bottom, number 36, because you will have a real life application problem just like number 36. Also be aware that all of that time that we spent reviewing, foiling, and factoring, be ready to foil and factor on this test tomorrow. And then here is 10-7. And again, we just did the warm-up for that. But again, be able to write the equation, be able to pull out a center and a radius from an equation, and also be able to graph it.